Okay, now we're going to do the 310 homework. And I'm gonna try, if it's reasonable and feasible, I'm gonna try to do this homework for you guys using both long division and the box. Because if you like the box better, you know how to do long division, but you don't have to do it, okay? Oh, actually, they do have a question like that. Okay, good. I just wanted to make sure you could see how the long division problems look in the box, okay? All right, a student tried to divide this by this, but they made a mistake somewhere. So let's go look at their work and figure it out. And honestly, sometimes it's really hard for me to follow someone's work. So I do like to do it myself and then compare. Now remember, if you throw some parentheses around that, you'll possibly catch yourself on a mistake later. Question number 1, what do I need to multiply x by to get x cubed? And that's x squared. So I write down the x squared. Next, I need to multiply x squared by x squared plus 8, all right? So first, I'm taking the x cubed, and I'm seeing what I need to multiply x by to get it. So it's kind of the same as dividing them to get x squared, that one up here. Now I take that x squared and I multiply it by x plus 2 to get x cubed plus 2x squared. This number, this polynomial goes right under here. And then what you need to do is subtract. Now, when you subtract, everybody's sign changes, right? So this is like a minus right here and a minus right here, which then ends up giving me these two canceling and these two becoming negative 8x squared, and then I gotta drop down the next term. Okay, let's go see. Have they done this so far? They got the x squared, they got the x cubed plus the 2x squared, they subtracted, got the negative 8x, and they brought down the negative x. So far, I don't see a mistake. Okay, now we repeat. Now I need to see how many times that x goes into negative 8x squared, which means like divide them. Okay? Or imagine that this number is inside the box and that you have x right here and you're trying to figure out what goes there. You guys are really good with the box, so whatever way you do it, I don't care, it's negative 8x. So negative 8x goes here, and then I need to multiply negative 8x by that x plus 2 to get negative 8x squared minus 16x, and that goes here, negative 8x squared minus 16x. And then I need to subtract, which means go change everybody's sign. That becomes plus, and that becomes plus. So then this cancels, and here I have negative x plus 16x, which is 15x. And coming over here to look at what they did, look at that negative 17x they got. Didn't I tell you guys this is where you would make most of your mistakes? It certainly happened that way for this poor student. Right? Did all this work and then messed up right there. Okay, it should have been this, not this. Okay. Sure, explain how to fix it right here. And then you could keep going from there. So that would change stuff. Then the 30 would come down next to the 15, and then you would do a 15 here. And then you would multiply to get 15x plus 30, and then you would subtract these to get no remainder. Whereas when the mistake had happened, there happened to be a remainder. Okay. All right. Now we're gonna look at number 2, and that one doesn't even require any long division. Okay? No long division required here. all you gotta do is look at this polynomial. Notice how everybody has an x squared? So look, they just took out the x squared. We can do that. Let's take an x squared out of x to the fourth minus x cubed minus 6x squared. We end up with x squared minus x minus 6. And then I get really excited thinking I'm done. However, then I notice they have 2 sets of parentheses after their x squared, and I only have 1, which means I gotta keep factoring. Which means I gotta figure out what multiplies to negative 6, but adds to negative 1. Negative 6, negative 1. So that's gonna be a negative 3 and a positive 2. Negative 3 times positive 2 is negative 6. Negative 3 plus 2 is negative 1. So that means that this here, this part factors even further into x minus 3 and x plus 2. So they want me to write the one that's positive first and the one that's negative second. No problem. We'll put x plus 2 first and we'll put x minus 3 second because the order doesn't matter. Okay, final answer right here. Let's keep going to number 3. Number 3, they don't say do long division. So we don't have to do long division. How about this? How about we do one of these with long division and one of these not with long division? So let's do this one with long division, okay? What we need is to come here and put this guy in here. Please remember, when we're dividing, every term needs to be accounted for. So 3, 2, 1, 0. Nobody can be missing, and they're not. If someone was missing, I'd put like a 0 in their place. And then the 2x plus 4 is one of the factors. That's what they're kind of telling me here. 2x plus 4 is one of the factors. So I put that out here. And then I start dividing. So 2x goes into 2x cubed, x squared times. That means that x squared times 2x equals 2x cubed, if that helps you see it a little more easily. This number times this number should equal that number. And then now I need to multiply this by this, which, throw parentheses so you don't forget to distribute. X squared times 2x is 2x cubed. X squared times 4 is 4x squared. And now we're going to subtract, which means we're going to change everybody's sign. This cancels, and this is 10x squared. And this is 8x. I drop it down. Now, 2x times what is 10x squared? That's 5x. 5x times 2x, remember distribute, is 10x squared. 5x times 4 is 20x. Let's go and subtract by changing everybody's sign. And this cancels. And 8x minus 20x is negative 12x. And now we drop down that negative 24. So what do I need to multiply 2x by to get negative 12x? And that's a negative 6. Negative 6 times this is negative 12x minus 24. So now I subtract by changing everybody's sign. And this cancels, and this cancels, and I have no remainder. Okay, so what does that mean? That means that this guy factors into 2x plus 4 and x squared plus 5x minus 6. And I'd be done, except they have 2 more factors, and I only got 1 because this thing itself factors. So we factor that by seeing what multiplies to negative 6 and adds to 5. Okay, that's 6 and negative 1. 6 times negative 1 is negative 6. 6 plus negative 1 is 5. So that means that this factors into x plus 6 and x minus 1. And they want the positive one first and the negative one second. So almost exactly like the way we did it. There it is. All right. Okay. Now number 4. I could do it just like I did number 3 with long division. Okay, but as promised, I want to show you the different methods because you could do it whatever way you want. All right. For this one, 1, 2, 3, 4, 5. I noticed 5 terms across, so I think I should make a box that goes 5 across. So 1, 2, 3, 4. And then now let's put the x and the negative 1 here. This is one thing we know is a factor, we put it there. And now I'll start with putting the first number or the first term in the first box, and then the last term in the last box. And let's just start solving the puzzle, okay? I find this so much more enjoyable than this long division. If that's an x, this is a 6x cubed right here to give me the 6x to the 4th. And then 6x cubed times negative 1 is negative 6x cubed. And then over here at the end, if I have a negative 1 here, I must have had a negative 8 there to give me that negative 8. And then now with the x and the negative 8, that's a negative 8x right there. And that's about as far as what I have done so far can get me. I now have to look at the terms in the middle to help me with the rest, all right? The 6x to the 4th and the 8 are what got us here. They're done. They're going home. They're taking a break. And now it's up to these guys. Notice that my x cubed term in my answer is a negative 2x cubed. But my x cubed term inside my box currently is a negative 6x cubed. That means I got to add another 4x cubed to it in order to turn it into a negative 2. So remember, if you take what you have minus what you want, you will get what you, oh no, I did that wrong. Just kidding. Sorry. If you take what you want to end up with and you subtract it from what you have right now, you will get what you need. So the negative 2 that we want, subtracted from the negative 6 that we have, gets us the 4 more that we need. Anyway, it's just a little trick to help you figure out this number if arithmetic's not your favorite thing. Okay, now that there's a 4x cubed there and there's an x there, that gives me a 4x squared here. And then 4x squared times negative 1 is negative 4x squared. And here I am stuck again, so I go look at what my x squared term needs to be. I already have negative 4. I want negative 14, so I need another negative 10. Because negative 10 and negative 4 together are negative 14. So there I am with that. And then now that I know that, that makes this a negative 10x. So that times the x can give me this. And negative 10x times negative 1 is positive 10x. And the positive 10x that I have, with the negative 8x that I have, gets me, oh, I did something. I didn't need this many boxes, but it's okay. It doesn't hurt. The 10x that I have minus the 8x that I have already is giving me the 2x that I want. So that confirms that everything is good. I actually don't need this area right here. So, whatever. And here's the answer. Remember, the answer ends up on top, if you remember from watching the previous video. So this is a 6x cubed plus 4x squared minus 10x minus 8. And you guys, even though this was a longer problem, because this was a 4th degree, it was a longer problem than this one. It still, to me, was easier. Like if you did this problem with long division, it'd come out even longer than number 3 did. Okay. So now, here's someone who did this with long division. did this problem with long division. We're going to show them how it would have looked with the diagram. So we're going to put the x and the 2 here, and we're going to put the negative x cubed here, and we're going to put the negative 16 here, and we're just going to start. So this must have been a negative x squared. Oh my gosh. That. And then negative x squared times 2 is negative 2x squared. Oh my gosh, that's that. And then, in order to get the negative 16, we need a negative 8 right here. That's that. And the negative 8 times x is a negative 8x, which is that. And now, going to my method of, we have a negative 2x squared. What we want is a positive 4x squared, which means I need to add another 6x squared to it to make it happen. That's that. Oh my gosh. So the 6x squared results in a 6x needing to be here, which is right there. And then the 6x times the 2 gives me the 12x here. Look at this. Look at how this is literally long division, but just so much better. I swear to you, you guys, these Desmos people, these amplified people, I swear we all need to write them a thank you letter, because this is so great. So great. Okay, let's move on. They're saying that x minus 1 is a factor of that big old thing. So they want me to find all the rest of the factors. Because this is like me coming to you with this ginormous number, like 1,782 or something. And I'm asking you to find me the factors of it. And right now you're like, I don't know what goes into 1,782. Well, if I tell you that you can divide that by something and you do divide it, you'll get a smaller number that's more manageable and easy to find the factors of. Same goes for polynomials. If I take, okay, I'm gonna do one less boxes across than the number of terms. Because last time, actually, hold on. Let me first look at what I have and make my life easier before I get started. They want me to find all the factors of this, okay? Well, x minus 1 is 1, cool. Now looking at this, if I can factor this myself, that's nice, I would. And I can't really factor it all the way myself, you guys, but I do notice that every term has an x. That's a GCF situation. I can take out the greatest common factor of x to be left with x cubed minus 3x squared minus 22x plus 24. That's already simpler than what I had to start with. And it shows me that x is a factor right here. So there's x minus 1 and x so far. Okay, now I have this. And I want to see what other factors it has. So if I take the first term and put it in the first box and the last term and put it in the last box, and I divide this by the factor that I know, which is x minus 1, I can get more factors. So that gives me x squared right there, gives me negative x squared right here. This gives me a negative 24 right there. And then if this is a negative x squared, but I want negative 3x squared, I need another negative 2x squared right there. If that's a negative 2x squared, then this is a negative 2x, and then times this is a positive 2x. And then negative 24 times x is negative 24x. Is negative 24x plus 2x negative 22x? It is. Everything's great. That means this is another factor. However, looking here, I don't see that, which means they want me to keep factoring this, because this factors, all right? This factors into whatever multiplies to negative 24 while also adding to negative 2. So that's my 6 and 4 with a negative 6 and a positive 4. So this also factors into x minus 6 and x plus 4. So coming over here, x minus 6 is a factor, x plus 4 is a factor, and nothing else. All right. Stand for Okay. They want me now to just keep doing this. We're doing more, all right? They're giving me a factor. They want me to write this as a standard form polynomial. You guys, I noticed this. I don't know if you would notice this because it doesn't work for all of them. But I noticed that I can just factor this by the box directly. I'm not going to do it. It's not fair. How would you notice that? Fine, we'll do it. Okay, we'll put the x plus the 2 here, and we'll put x cubed here, and we'll put 4 here, and we'll just start dividing, okay? So this is x squared, right? I'm finishing this Sudoku, polydoku. 2x squared here. If that's a 4, that's a 2. And if I want a negative x squared, but I have a 2x squared, I need a minus 3x squared. All right, I gotta take the 2 I have away and take an extra one away to make it negative. This is negative 3x. Negative 3x times 2 is negative 6x. Oh man, that was so hard for me, you guys. I'm out of juice. I'm so tired. What's happening? What goes here? 2 times x, 2x, and 2 times 2 is 4. So I just factored this basically into x plus 2 times this. However, if this keeps factoring, I got to keep factoring it. If it didn't factor, I would just put that here and be done. But I can look at 2 and negative 3 and at least be suspicious that I can multiply to get 2 and add to get negative 3, which I can. Negative 2 times negative 1 is 2. Negative 2 plus negative 1 is negative 3. So that means that this factors even further into x minus 2 and x minus 1. Okay. Here I am with this. We're going to do the same thing, you guys. We're going to do the same thing. Boop, boop. We're going to divide this by x plus 3 and see what this is. All right, so first term and last term go in. X goes into x cubed, x squared times. X squared times this is 3x squared. And then 3 times negative 20 is negative 60. So this is a negative 20x. Now I'm stuck. So I check in with that x squared term. I have 3x squared. I'm supposed to end up with 1x squared. There must have been another 1x squared. All right. Alrighty. Then this is x. And then x times 3 is 3x. And 3x minus 20x is negative 17x, just as I need. So that means that this factors into x plus 3 times that. So x plus 3 is good. However, this, we got to be suspicious that it might factor still. Because I'm thinking I can multiply to make negative 20 and add to make 1. I can. I'll prove it. Negative 4, positive 5. Does it all. Okay, and last one, you guys. Place an integer in each box to make the statement true. Use an integer from 0 to 9, no more than once each. Guys, I'm so tired. I don't want to do this. But let's do it. Let's do it, because I'm sure you're tired too, and I wouldn't accept that as an excuse from you. So let's not be hypocrites here. Okay, let's see what's going on here. I have some big old thing. It's a quadratic polynomial that I'm going to divide by this. So like something x plus something. This part is what I just did here. And then this is a quadratic, so all I need is 2 boxes right there. So I want to get something x plus something right here is unknown. This is unknown, and this is unknown. And then when I do this division, I need to end up with 2x plus 2 as the answer. And remember, the answer ends up at the top. Okay, we can do this. So 2x times x is 2x squared currently. But the problem is, oh no, there's no problem yet. Let's see. Let's write in blue. If this was a 1x, 2 times 1 would be 2 right there. And so far I will have used a 1 and a 2. The 1, remember, goes in here. And the 2 is in front of the x squared, so that's this. And then, oh, see, but then, who knows if it's a problem. Then I have 2 times 1x, so that gives me a 1x here. Oh, I'm sorry, that's a 2x. I don't know why I said that. Gives me a 2x. 2 times 1x is 2x right there. Okay. And then 2x times whatever this is needs to give me this. And the key is when I add this to this, I should get this number, and it needs to be a 2-digit number. And then I cannot use 1 or a 2 because I've already used 1 and 2. So like what I'm kind of thinking is to throw a number big enough here that when multiplied by 2x gives me a 2-digit number. So I'm thinking like 5 or 6. I'm gonna go with 6 because I can already tell 5 will give me trouble. And I'll explain in a second how I knew 5 would give me trouble. Okay, so 6 right there. So 6 times 2x would give me a 12x here. And a 12x plus 2x, oh, even 6 gives me trouble. 12x plus 2x is 14x, so I would need to put 14 right there. However, I can't use 1, so I need my 2-digit number to not have a 1 in it. How about we change that to a... Oh, that's not possible. Oh, no, it is possible. Ooh, but not if I can't use 2 either. See, the most I can do, you guys, is put a 9 here. And then 9 times 2 would be 18, and 18 plus 2 would be 20, and then 20 would require a 2 that I already used. So this has been, we've been like doomed before we even started by using the 2 and the 1. We can't do that. We need to save our 2 and 1 for later. We need it later. Okay, let's go back to the beginning. 2x right here. What number do we want here? Let's go with, let's try 2 this time. I just want to keep it as simple as possible for now. So that would make this a 1. Let's see if that works or not. This is 2x times 2x. That gives me a 4x squared right there, which means this needs to be a 4. And then now I need 2x times whatever this is to give me enough to add to a 2-digit number. Do we want to make this a 6 this time? Let's see what happens if it's a 6. No, if it's a 6, 6 times 2 is 12. And I already used 2, and I'm gonna use 1 when I do this business right here. So that's not good. Oh, wait, this is a 4 though now. Just kidding. Hold on. Since I changed that to a 2x, 2x times 2 is 4x now. Okay. I still can't have this be a 6 because 6 times 2 is 12, and I already used my 2. So let's go ahead and change that to something else. Should we go 7? And then 2x times 7, so this would be a 7 right there, is 14x. And then 14x plus 4x is 18x. So I need an 18 right here. So now, still I haven't repeated. Oh no. Oh no, this is 14 right here. That's a problem. They want only a 1-digit number right there. Wait, if I was smart enough to look at that first, I would have saved myself so much trouble. That's a 2, and this needs to remain a 1-digit number. Right here, you see? Which means, let's erase everything and go back and be more careful now. If this has to be a one-digit number, this number right here has to be like a 1, a 2, a 3, a 4. Okay, it can't be a 1. It might be able to be a 1. It can be a 2, it can be... I don't see any problem with these. I don't know which one could be problematic. Let's save the 1 because it seemed like we might need the 1 later. Let's go with, I don't know, let's go with 3. So if there's a 3 here, 3 times 2 is 6 here. So that gives me a 6 here and a 3 here. And then that 2 times 3 is 6. And then over here, I need something like a, I don't know, let's just make up a 5. No, I can't have this turn into a 2-digit number. Let's go with 4. Oh my God, I doubt anybody's even watching anymore. Okay, 2 times 4 is 8. That's a problem. That's a problem. It can't be 4 because then I would have an 8 here, and 8 and 6 would make 14. And I already used the 4 right there. So I can't make 14 if I've already used the 4. This is unnecessary. This problem is unnecessary, you guys. I'm irritated. Okay, let's go with, all right, I used the 3 and I used the 6. I said I can't use 4. Can I use 2? That'd be a 4. Ooh, I can use a 2. 2 times 2 is 4x squared. And then 2 times 2x is 4x. And 4x plus 6x is 10x. And this is a 2. And this is a 4. Oh my God. Here's one possible solution, you guys. I'm sure there's more. But my brain is done. Like, I'm done. That was really hard to do with how tired I am. Don't worry. Remember, the one question before the spiral review is not one to lose sleep over. But holy crap. Okay. Bye, you guys.